Hi everyone. In 4.2, we're going to work on creating slope fields, which is basically your visual of differential equation. So I actually think it's pretty amazing. You can use the differential equation to help you figure out what slopes your solution curve would have. And then if you kind of just sketch those slopes in, you can picture what the different solutions curves will look like. So I'm going to work through an example. I think the big thing here is just to get you in to figure out how these slope fields are made. And then we'll answer some questions about them. But once you get that, I don't think that the questions are super tricky. But I think it's a really neat section. I love this section. So I'm going to work on this one, dy dx equals y over x. And what you want to remember is that dy dx means slope. So this is literally telling me that if I were to draw a solution curve, and we know that when we integrate, which is a way to solve differential equations, we get infinitely many solution curves. What we've seen so far is that they all differ by a plus c, but that can change. So here we're being told that of all those infinitely many solution curves, the thing that they share is the fact that their slope is their y coordinate divided by their x coordinate. So you can basically pick any point in the xy plane and you can think about, okay, do I have a slope and what would my slope look like? So to pick an easy one to start with, I'm just going to make a small grid here. I don't want to spend too long boring you with my working through, but just get you the idea. Okay, so this point, let's say this is 1, 1. The slope at 1, 1 would be your y value of 1 divided by your x value, oops, I can't talk and write, of 1, which is 1. So at this point, I'm going to try and draw a slope of 1. And it just needs to be a little, you're basically just drawing a tick mark to give you an idea of what that slope looks like. I can pick another point, 1, 2. And at 1, 2, my slope is going to be, I won't write down all of them, but it's going to be 2 divided by 1, which is 2. So these aren't going to be perfect, but you can kind of count these little boxes. So if we go over 1 up 2, it looks about like that. So my slope, and that's kind of wibble wobbly, but looks something like that. And then at 3, 1, my slope's going to be 3 divided by 1. So I notice that they're getting steeper as my y value gets bigger, which makes sense when I look back up at this fraction. If the top is bigger, the whole thing should get bigger. I'm going to work my way down now, and I notice something really nice when I go down to the point 1, 0. Since the top is my y value, the slope is going to be 0 divided by 1 is 0, and that's going to be true for every single point on the x-axis. Anywhere along here, doesn't matter what your x is. If the top of the fraction is 0, the whole thing is 0, so we're going to have these horizontal slopes. Ooh, I should be careful about this one. I remember to skip it, and then I went back and put it in. Well, we're thinking of zeros. That's a really good thing to kind of pick out what makes the whole thing 0. But also, when there's a fraction, we know that the denominator being 0 tells us something quite definite. We know that our slope is undefined whenever x is 0. So that can mean a couple of things. For a lot of what we see, what that means is that your slope is vertical, and that's why it's undefined. But we don't know for sure, so you can kind of, I don't know, mentally imagine this, but don't feel too stuck on it. It can also happen that there's a sharp corner there or something along those lines. So I'm going to actually leave these so I don't tie myself into that. But just remember that anywhere along the y-axis, your slope is undefined. Okay, to fill in a few more of these, so if I go down to 1, -1, I'm really tempted to say it wrong, then your slope is -1 over 1, so -1, and then this is going to be -2 over 1, so slope is -2, slope is -3. And you just kind of work your way along and see what happens. So for example, if I go to the point 2, 2, my slope is 1 again. And in fact, I can kind of spot a pattern there maybe, that anytime my y is equal to my x, the slope is going to be 1. So I can just work my way along the y equals x line and say, okay, for all of this, my slope is 1. You don't have to do that. You can just go point by point, but you can sometimes get some really neat things. You could also notice that if your y is the opposite of your x, then your slope is going to be negative x over x, -1. So for example, if I'm at -1, 1, then my slope is -1. And if I'm at -2, 2, my slope is -1. And I just don't want you to think this is always the case. The fact that the slope follows that line is not necessarily true. You could have something like, when my y is equal to my x, my slope is always 0, or when my y is equal to my x, my slope is always 3. There's lots of things, so that's kind of coincidence here. Okay, so one thing I wanted you to see, and you can play with this, make sure you're trying to understand how to do these by hand. But we do have a link here to a Desmos slope field generator, and you can plug in your equation to check out what's happening, so you can edit this thing to get what you want. So if you follow that link, you should get here. And this is actually, oh, hold on, let me look. What did we want? We wanted y over x. So this is actually close-ish, but we're going to want to edit a little bit. Why did that capitalize? There we go. And it will populate that for you. So instead of having to watch me sift through that whole thing, there it is with a lot more detail. So this is everything from 0 to 10. So it's not zoomed in quite as much as ours. Sometimes some of the finer details don't show very well on this one, but it is a good way to come back in and check yourself if things are getting weird or trying to get a better visual. I provide the answers for the ones that you're about to work on, but you can also come in and look here if that gives you a little bit better picture. Okay, so I'm going to want you to go ahead and try a few of these on your own. So you don't have to do a perfect all filled in slope field, kind of work through like I did. Try and get a little bit of information in each quadrant. Think about where slopes are 0 or undefined. You're first going to choose one slope field that only depends on x. So in mine, I had to plug in an x and a y coordinate. But for example, if you were working on this one, if you picked the point, let's pick a point. Let's pick 2, 1 versus 2, 2. The only thing you have to plug in to get your slope is an x value. So if I plug in x equals 2, I'm going to get 1/3, and it doesn't matter what my y is. So any point along that x coordinate y equals 2 is going to have the same slope. And for the next one, you're going to choose from the second row, and your slope's only going to depend on your y. So now if I choose points 1, 1 and 2, 1, since I really only need to plug in my y value, those will both give me the same slope. So I'm looking at this one right here. So I'm going to get 1/2 when I plug in y equals 1, and that's not going to change if I'm at 1, 1 or at 2, 1. So those are a little simpler, but also can throw people off just because it's a little different than mine. And then on the next page, you'll pick one like mine that has an x and a y. Doesn't matter which one you pick. I have answers for all of these. In fact, you can do multiple if you think you need a little bit more practice. And then we'll look kind of back at this just a little bit. We'll look at the answers and talk about the solution curves in the next video. So I'm going to leave you to give that a little practice, and then we'll pick up from there.